Hi, you guys. We are going to take notes today over synovial joints and bone ossification. And then at the end, you will be watching Crash Course, the skeletal system. I believe it is a 14-minute video. So that 14-minute video, 13 minutes, will be at the end about the skeletal system. So here on the screen, you can see that we have 6 different synovial joints. These synovial joints are all equally important in the body, super important. Your ligaments and the bone shape are going to determine the possible movement in between two bones. Okay, so please remember that you have 2 types of articulations or joints that are going to have limited or no movement. Those are going to be your fibrous joints, like the sutures in your skull, as well as the cartilaginous joints, like the ones between your sternum and your ribs. Okay, and then here we have on the screen the movable synovial joints. Okay, so if you look at A, you're going to find out that A is gliding joints, and you'll notice the picture is the clavicle and the manubrium there. That's all part of the pectoral girdle. Again, we talked about that. And the gliding joint also is going to be found in your vertebrae and in your wrists. So you'll notice the little diagram of the arrows with the colored disc here. You can see that it'll move a little bit in each direction, but it's not going to move a lot. Okay. The second joint that we're going to look at is the saddle joint. It'll be the second joint that you're going to write about. And there's only one. It's not here on the screen, but it's your thumb. Oh, yes, it is right here, your saddle joint. Sorry. So your saddle joint, you can look at the shape of the metal thing here, and you can see here that it can move in each of the directions, and it rotates back and forth more than anything else. So the saddle joint is only one of them in your thumb. Then we have a hinge joint. The hinge joint, like a hinge on a door, you're going to have one will fold up to meet the other. So when you think about your ulna, remember your ulna makes up your elbow, your humerus, your upper arm. So the ulna can fold up to your humerus and touch your shoulder. Okay, so that's a hinge. You also have hinge joints, say at your knee. Okay, hinge joints. Hinge joints. All right, the next one is your pivot joints. So your pivot joints, we have C1, again, the atlas, sitting on C2, the axis, and that's going to allow this pivot back and forth motion. Notice the dens there is going to keep everything in line, so that way your spinal cord doesn't get tangled up or mangled in any way, shape, or form. All right. Then we have our ball and socket joint. Our ball and socket joint is what I showed you yesterday with the hip and the condyle. That's why we had to know condyle, because the condyle fits into the joint there. Okay, so you have an all-around movement. Your ball and socket joints are going to give you the most movement of any joint in your body. Okay, and then there's the ellipsoidal joint, and the ellipsoidal joint is a little bit odd. You can see the shape here, and you can see the shape here. It mimics slightly the ball and socket with the concave and the convex, but just a little bit, not a whole ball, not a whole socket there. But all of those little carpals in your hand, there's the ulna and the radius, so we know those are the carpals. They're all going to slide past one another with just a little bit of motion in our ellipsoidal joints. Okay, so there are the 6 joints you need to know. Here is the slide with those 6 joints. Okay, and there they are. So if somebody wants to pause the screen and you guys can write those down, then we will get to bone ossification next. But those are the types of synovial joints and all that you'll need to know for synovial joints. All right, moving on. Now we have the intermembrous bones and endochondral bones. And this is where you started as a fetus, okay? So at 8 weeks, your little fetus started to make bones. Look at those little pieces of cartilage in the hand. Those are very, very interesting to see. Over time, your cartilage is then infiltrated by blood vessels. and those blood vessels will start to enter the cartilage, okay? They're called chondrocytes. They are at the center of the growing cartilage. They are going to accumulate that collagen fiber in there, and there's going to be a calcifying matrix. So that cartilage inside is going to hold on to the calcium and the phosphorus, and it's going to start creating bone. And as it creates that bone, those osteoblasts are going to start demanding more oxygen and nutrients, which is going to cause a blood vessel to then infiltrate that cartilage piece and supply those cells with blood. Well, this is the development of the marrow cavity and the site of primary ossification, okay? So those osteoblasts are going to continue to work in order to form that bone. That whole inside area is going to start with the compact bone here. You can see the epiphyseal lines at the end. We still have the epiphysis here, blank and empty, doesn't have the blood vessels yet. But that bone shaft is going to thicken, and the cartilage near each epiphysis is going to be replaced by the shafts of the bone. Okay, so eventually step 5, the blood vessels invade the epiphyses, and the osteoblasts from the secondary centers of ossification will enter, and now we're going to start having the makings of the spongy bone. Okay, so real quickly here, I have an x-ray of the epiphyseal plate. You can see that's going to be the site, so the bone's actually going to grow away from that, which is kind of interesting. Okay, and then we're going to end up with bone ossification. So if you want to go ahead and pause this now, copy this down, and then I'll explain it in a second. All right, pause. Okay, so bone growth and width. Your bone, when it starts out nice and small, it needs to grow in width. And when it does this, the blood vessels are around the outside. And those blood vessels work with the osteoclasts to solidify the matrix of calcium and phosphorus. Okay, so there's going to be collagen fibers in there, but what's going to end up happening is the blood vessels are on the outside. They're going to continue with these periosteal ridges, and the periosteum is going to continue to solidify the phosphorus and the calcium. And so you're going to end up with this build around, which is going to make a central canal. You have the blood vessel is going to come up that central canal, and eventually over time it's going to end up being completely circled, and now you can start to see the lamella forming. Okay, so Haverson Canal is also known as the central canal. You can see it made here. Haverson Canal is on your test, so pay attention to that. The Haverson, Haversan, Haverson Canal. Okay, all right, so bone injury and repair is something that we're going to talk about when I get back, so that's where we're going to end today. You should write a line across your notes under bone growth and width and write summary. So your summary is going to include everything from where we started the other day when I was... sorry, I'm looking for the slide as I'm talking. Okay, so skeleton right here. I guess it started, with the surface features of bone. And notice I have the condyle here. I asked you all to add condyle. I think second period did not. So second period, you guys need to add that condyle to the surface features of long bones. So then all of that will be in the next summary, okay? The skeleton bones, the axial skeleton, the appendicular skeleton. All right, also you guys, for homework, I want you to do the next section in your homework packet, and I don't have it right in front of me, so a little bit tonight and a little bit Monday night will allow you Tuesday, Wednesday, Thursday to finish your lab that we're going to need to finish, as well as work on your homework packet. So summary tonight, do your questions as well, and I will see you all on Monday. I hope you have a great weekend. Thank you.